presentations. Let me carry forward from what my colleague Umar talked about me helping organizations. So as part of this initiative, because we can't have a 1 hour session in which everything can happen all at once, what we are planning to do is we have some topics, some critical topics, and we will be basically establishing and planning multiple webinars. So there'll be some topics which might have 1 or 2 parts. So that means 1 or 2 webinars. And there will be some other topics which might have even 5 or 6 parts or more. So depending upon the complexity of topics, there will be some parts to webinars. This particular webinar is an initiative and it is an attempt to ensure that the participants get a very basic high-level feel of the topic, which is about variation, because you all, whatever you are working on, I'm sure you are dealing with processes and you are dealing with variations. And I hope that this webinar will help you. This first part will help you to, first of all, understand what causes variations, what are the different types of variations, how can you, okay, in your work, identify some signals and variations, and what is it that you could do about it in order to have practical benefits. So we are talking about really practical benefits here. Okay, I request all of you to switch off your videos and to be on mute, as that can sometimes distract people from looking at the complete slides. So that's a request. And if you have any questions, please keep writing in to me. You know my name, Himanshu Karkhanis. Feel free to write in your questions. In fact, you have some supportive points. I'll be very happy to share it with the other participants as well. So please keep your thoughts and your questions coming in. So let's begin. Now, before we go into the slides, I would definitely like to start with some definition, because we need to understand what is it that we are talking about here. So when we say special cause and common cause, we are pointing to variation, in fact. Now, the way variation is defined also makes it very important, because that would have implications on how you look at variation. So for example, variation can simply be a change or some difference in some measurable parameters as compared to what you wanted it to be. It could be a deviation in some specification. It could be a distinction, that means some difference again in some attribute or some parameter. Basically, we are talking about a change. Okay. However, let's understand from our experience and your experience that variation is part of life. We are not talking about, or I am not going to give you something where you can just turn off the variation like we turn off the gas or just switch off a light. We are talking about controlling the variation. Everything that is alive has variation. Okay, how do I know I'm alive? Let's attach an ECG and electrocardiogram, and then maybe you can display it on the monitor, the one that is shown in films. Now, what happens if a person is dead? What do you see on the monitor? Straight line, right? So anything is a straight line, no variation means no process, nothing is happening. If something is happening, there will be variations. Okay, so if whatever work you are dealing with, some of you may be in service industry, some of you may be in software industry, some of you may be trainers, some of you may be lead appraisers. Everything that you do will have some variation. And why not? Let's look around. For example, let's look at variation in local temperatures. The temperatures vary every time. There are gradients. If you take a public transport, you will notice that there is a microsecond at least difference in arrival of buses and trains, even flights. for that matter. If you're in the manufacturing industry, let's say you're manufacturing something as critical as a syringe, there will always be variations in the thickness of the needles. Those who are in that industry would know that, right? There is always a microtesimal variation. There is always there. Your response times to customers, in case you're dealing with customers, you will not be able to always respond to customers at the same within the same reflex time. Okay. Stock markets, those of you who love to invest, you will notice that there will always be variations because it's alive, man. The process is alive. Okay. Sunrise and sunset times. Well, for those who might be worried that their process has a lot of variations and they're not able to do things exactly on the same time every day, well, I have some happy news. The sun also does not rise and set every day at the same time. Okay. In fact, there's a lot of difference. There is a very significant decrease and increase in the timings. Okay, as we move into the year. The Earth's rotation speed, for those interested in science, that's also, we now have instruments that can measure the Earth's rotation and speed, and it's not like constant. Okay, for practical purpose, it can be, but there is still some variation. The work that you do, the same type of work that you do every day, you will also take different times every day, right? So that's why variation is everywhere. Now, with this understanding, let's go deeper into the skeleton of variation of this creature and let's try to understand what it is made up of. So variation, let's understand some factors. Now there could be intrinsic factors, there could be extrinsic factors, meaning that intrinsic means from the process itself. So the variations are coming from inside, from within, from exactly what you do. Whereas extrinsic would mean those external factors that are influencing your process and because of which there can be a variation. Okay, but regardless of whether it is intrinsic or extrinsic, both these factors have two things in common. Variation broadly can always be categorized as common and special. In other words, or to elaborate more, variation can happen because of some causes that are very common and everyday, or variation can happen because of something that has happened on a particular day. Okay. And how do we identify, however, whether this variation is common or special? So let's have a look. So we will have a look at how to identify what does it mean by having common causes of variation, what it means to have variation because of some special causes. All right. Let's look at some more things related to common cause of variation. What do you mean by, or what do I mean by saying common cause? Okay. Now, variation which is always there, inherent, is common cause. Variations that you see every now and then, I'm not talking about those extreme deviations, but the difference in temperatures, which is well expected. So that is always there, right? And they happen because of the existing interactions between, let's say, two humans, human and machine, machine and machine, that is other machines, software and hardware, some other firmware, components of the environment, like there are clouds and rain and wind and earth and soil and water. So all these interactions which are there in nature, they all show common causes of variations. Okay. So that's natural. One characteristic of common causes, the causes will also be natural causes. There will be nothing artificial about them. They will always be there. That's what we have written. And in fact, as I was trying to summarize, if it's a process, it will vary. So it will have at least common causes of variation. Okay. Compared to this, now let's look at what it means to have special causes of variation. So special causes of variation are always due to some kind of an influence if it's external, that means there are external factors at play. If it's internal, then it means it is induced or it is incited. Now, this may be deliberate. That means you're knowingly doing that. Maybe you are introducing a new tool, right? You want to automate something and you introduce a new tool. That can lead to special cause of variation because there are always some disturbances, some unexpected disturbances whenever something new or new component gets added. So it could be, or it could be unknowingly happening, but it could be artificial. In short, it's not natural. It is not expected. So when we feel too hot, that's when we always debate, on let's say WhatsApp and all the social media circles that hey, there's something too wrong. I mean, it's too hot. We know we live in a hot country like maybe India, but it's too hot. It never used to be that hot. And then it's broken the record of the past 10 years, right? So there's always some cause, some special cause sometimes behind variation when it goes beyond certain limits, right? There could be some environmental factors as well, as we are just discussing. It could be event driven, that means may not be part of process as well. But there should be a way to find out, isn't it? There should be a way to find out whether variation is common or it's special. Now, let's do that. Let's try to attempt that in this part or this series of webinar. Okay. So common cause, let's look at some attributes, like how do they manifest? Okay, how do the common causes of variations manifest? If the variation is due to common causes, then your process is basically in control, all right? And because your process is in control, it also makes it, a more, I would say, predictable. Okay, so that makes this process more predictable. Okay. And because it makes the process predictable, your process is basically functioning as expected, even with those variations, right? And you can't assign any cause, any specific cause to that. It's just inherent. That's what makes it so, like a common cause, right? And common cause is also called as noise, but well, noise can be good, right? So as I give an example of a living human being without any problems to the heart, God forbid. And if you attach some machine and that shows the heartbeats wearing, that's called as noise. But then it's good, right? It's good that we have the noise. No noise, no person, right? And well, common causes are universal in nature. So everything has a common cause of variation. But because your process is in control, okay, that's what makes it stable. So a stable process helps you to predict with some good accuracy. If you are part of process control, or if you are a quality manager, or even just a project manager, you would understand how necessary it is to have, processes that are stable. So they can be stable if your variations only have common causes, right? Now, let's go ahead and see some more attributes for special causes now. So as compared to, let me just put this slide back again. So these were the attributes of common causes. Now, exactly the opposite stands for the special causes, okay? So special causes are uncontrolled. I mean, you don't have any control on when they can happen. And that's why it makes it unpredictable. You don't know when the stock market might just collapse, but we can definitely predict that there will be ups and downs because collapsing is like a special cause. This is totally unexpected many times, and there are always assignable reasons, okay, to special causes of variation. And that's why we call them special cause. So it can be considered as an anomaly, some extreme deviation. They are usually local in nature, so originating out of a very specific place. So if it's a special cause, you can be sure that it's not happening at every step of the process. It's localized to some area of your process. And because of special cause of variation, your process becomes unstable. And that's where you start facing problems in your projects, in your work. cost variations, schedule variations, effort variations, a lot of service issues and defects, etc. Right. Now, as an example, okay, what I have done is I have extracted some uh, data on the incoming time of a person. So let's say you're, working in a typical, let's say, organization in India, and you have a start time or office incoming time of 9 a.m. So 9 a.m. is a specification that has been mentioned to you, and everybody is supposed to be in office by 9, before or at 9 a.m. And you have some kind of a sophisticated device that measures when you are in office, right? So let me show you that data. I'll share my screen again. If you can see an Excel sheet, then what you can see here is these are the office times, right? And as you can see, this is hours, then minutes, and then seconds. And obviously, you can't be in office at the same time every day because there will be variations. But let's see for this data. Okay, so we have roughly 16 points. Let's see that for this data, what is the kind of variation and how can we find out if there's variation only because of common causes or variation because of some special causes. Let's try to find out, and we will use this data. I have used a statistical tool called as Minitab, though I'm not endorsing any tool. You can use any tool, even Excel is good for statistics many times. I will be showing you an example of using a method or technique called as control chart. And how can we use this data, and see something very interesting about what happens when, because see, this is just office incoming time, right? What would be so interesting about it? But let's see what happens when we put this data into the tool, and let's look at the output. Okay, so I'm going to take you back to the presentation. And there we go. I hope you are able to see the screen. Now, this is an output of a control chart. The data that I showed you has been plotted here. Okay. And you can see that this output has many colors and many things, many components. Let me explain in short. So this is a control chart because it calculates two limits which are called as control limits. Remember, specification limits are those that you specify. So I want that the specifying time, the cutoff time should be between 9 and 9:30, maybe 9:15. So I'll draw a line over here. But that's my specification. But that is my voice of Himanshu. But there is also something called as voice of process, which are the natural limits of a process, any process. They are calculated limits. So you can see two red lines on this chart. These are the control limits. So the upper one is upper control limit, and this one is a lower control limit. So these are calculated from two parameters. One parameter is this middle line, which we can call as a mean. So this is a mean of the data. Okay. And there is some concept called as standard deviation, which is another statistical parameter. Well, you don't have to worry about it. Nowadays, many tools in Excel calculates standard deviation. Again, to put it in layman's language, standard deviation means the distance of each point from the mean, how spaced out your process is from the mean. Okay, because mean is something like at the center of the process. So this is also at the center of the process. This is a mean line, and these are the control limits. Now, you can see most of the points are within these control limits, except one point. Now, this is a very special point. This point is called as an outlier because it lies outside, And what's so special about this outlier? Well, as I told you, these limits are not set by me or anybody. These are calculated. Now, any point that goes beyond this line, it means that your entire process is unstable or your entire process is not in control. The reason is, some of you might say, well, but what about the other point? They are inside, right? They are so safe here. Yes, but today it's just one point. If you allow this process to continue as it is, tomorrow you might have 2 or 3 points. Now remember, what is the meaning of this point being outside? What is this point? These are the office incoming times. So this point is going beyond like 9 hours and 49 minutes. And obviously you don't want to be late every day, right? You don't want to be late, in fact, never, like zero. So you must take care of this point. You must understand what is happening in this point, which is why something like a control chart can always help you. Though, of course, that's not the only tool that we can use. Now, in this example, what we have done is simply extracted the office times, right? Without worrying about which tool we are going to use. And we have plotted it in control charts. What has happened is it has shown you, first of all, what is the average, what is the mean time of you coming to office. It has also told you whether your process is stable or not. Now, again, somebody might object to this interpretation. Somebody might say, hey, how can my mean be 904 when actually it's just maybe one of the time that I have been, and one of the time I have been very late. But that's mathematics. Because of one large value, the mean changes, influences, right? So which is why to get the whole process in control, you must focus on this one point. Now, what are the things that we can do, right? So first of all, look at these kind of outliers, okay? Look at the mean, see if your mean is much beyond what you would want it to be. And apart from these outliers also, check if you can have some pattern. Maybe sometimes, you can see some points going down, going up, or very unnaturally steady. See, no variation also means something is going on, something fishy or nothing is happening, as I told you. So watch out for some patterns, right? Now let's take the same example of this office time and let's talk about this point. Now this means that somebody was very late on at least one of the days, the 8th day of the observation, if I can be specific. Now, what could have happened? Anytime, anything out of these 10 reasons could be the root causes. What you must now do is a root cause analysis. Maybe is the time taken by the elevator to reach your floor. So you're out of your house with a good buffer, but maybe the elevator has taken time. If you're living on the 2nd floor or 3rd floor, maybe using the stairs could be better or faster. Maybe there are too many intermediate stops on the ground, which happened on that day, unfortunately, right? Maybe the speed of the elevator had some problem. So maybe it should get checked by the maintenance engineer. It also matters what was the mode of transport taken by the person on this day, right? On that day when you had this outlier. Did that person take a car? Did that person take a public transport? Did he or she took a walk? Because sometimes you may be forced to take a walk, or you live very near the office, so you are too confident. And then because of overconfidence, you got late, right? Maybe you are taking a bicycle to office, you're a health enthusiast, but there's a puncture. Some kids have made some nuisance. What about traffic? Regardless of what mode of transport you took, maybe there's too much of traffic which blocked you, right? Office building security checks, because there are sometimes sudden security checks because of some panic situations happening in the world. And maybe you were not aware of that. And that's why you reached your office building on time, but you got late to the office. What about the time taken from your office building elevator to reach your floor? Maybe there are also intermediate steps and there are too many stops in between. Maybe. What about the speed of the elevator in office itself? That's unexpectedly slow, which is why it could be a special cause. Remember, we are talking about special causes over here. Okay. There might be a queue when you finally reach your floor on time. There might be a queue at the biometric scan, or it's a scan or thumbprint or whatever. So as you can see, if you want to really find out what happened, you must investigate all the sub processes, which now means that in order to be prepared for variation and dealing with variation, you should know the sub process and sub process components of your process, of your main process. It could be as simple as writing a code, but writing a code also involves so many steps. Am I using the right tool, first of all? Do I have access to the tool? How fast does this tool work? Is it upgraded tool? There are so many questions that can be asked. What is the technology platform which I'm using for writing the code? All right. How experienced am I? What time of the day or night am I programming? Maybe I had sleepless nights because of which I'm not in focus. So there can be so many reasons and so many steps to each process. You must have the capability of breaking down these steps. And just as we took an example of office time, so there are so many components as you saw, and any one of them could be the reason. But that's what you got to find out. Okay. Now, for example, what you can do, because with this root cause analysis, what can we do? Well, if you know that every time you have to wait for a lift, for your elevator, for 5 minutes, leave 10 minutes early, right? Check what is faster mode of transport, maybe waiting for a bus, or what could be faster? Could it be, I will better rather wait in the parking and not waiting for the bus, because bus will also have a lot of stops in between. Maybe I can use my car. Maybe I can use someone else's car, right? Sorry, this should be the slide. What about alternative routes? Maybe it's a new office, it's a new location. I have not explored any alternative routes, and there might be plenty. What about carpooling? That's a concept that was picking up some time back. And maybe you have some carpooling groups whom we are in touch with, or you can get in touch, and maybe because they have some set time frame, and maybe you can probably reach office on time, right? And generally, anyways, leaving home early to avoid peak hour traffics. But that can be an extreme step, because then it means that you leave 30 minutes earlier than usual, right? Then maybe if there are sudden, some unnecessary security checks, maybe you can create a pass, some entry pass or something, which you can show daily, and then that can help you to skip some of the steps. Maybe you got up late because of some, some discouraging events that happened. Maybe there are some sad things that have happened on that day. There are mood swings, there are health issues. We all forget things, right? You get it not because you started late, but you had to come back twice. So once you forgot the pen, and then you forgot that you didn't need the pen, right? So there could be so many reasons for you to forget, and there are so many things that you might forget. So that can also lead to special causes. So please remember, everybody, though this might look a little funny, but the attempt is to try to make you understand that there could be enormous number of innumerable factors at play, because of which you have special causes and special variations. Okay. Waiting for breakfast, and then you realize there's nobody home. So, well, it's you who got breakfast. It's not going to come automatically. You have to prepare it, right? It happens sometimes. And when there are many people who want to use the washroom at once in your home, and you're not able to get ready on time, and that can also be one of the reasons. So the reasons could be so personal, reasons could be professional, reasons could be in any of the steps from point A to point B. But that's what you have to deal with, that's what you have to investigate and analyze. Now, once you do that, once you do this analysis and you find that, hey, I know why I got late because of, well, I have a lot of forgetfulness. So I'll keep everything in my bag the previous night. That could be as simple as that. And then bingo. If I deal with this cause, why I got late on that particular day, what I'm essentially doing is not improving the process drastically, but I'm taking the first step towards improvement, which is I'm removing the messy part. I'm removing the special cause of variation. How have I removed it? Not by removing the data point, but by taking actions after identifying the most likely possible cause, the root cause. Once you remove the special cause of variation, and when all your points, as you can see, when all your points are within these two control limits, then your process becomes what is called as stable or in control. And this variation now is only the common cause of variation. It can be safely called as the common cause of variation because there is no assignable cause here, because the process is safely within the control limits. Okay, so of course you have to check after taking action. So you'll have to, whatever data it is, I'm sure you will now relate this data with something of work data, but I deliberately wanted to give a non-technical example. So I would not like to have an example of defects and service industry response time. That's so very typical. So which is why I thought I will take an example of office time. So whatever is your process, check before and after, compare if the solution has worked. If not, go back again. So that's the flow chart that you would have, right? Let's go ahead. Now, some of the actions that you could take or you have taken in your special cause that we have seen is splitting up the process into many sub-processes, checking if each of these sub-processes is measurable, because only then you can come to know where things can go wrong. Use some diagnostic tools like control chart, fragment your data, break up your data, split your data, group your data into categories, right? Identify signals, check the variation, check the patterns. You can use something called as 5-why analysis, which simply means asking why 5 times, right? And hopefully by the end of the 5th why, you will come to know the reason for something. Now remember, there is a difference between finding the root cause and finding all the possible causes. You need to do both. When you find the root cause and you take action successfully, that means you're removing the special causes of variation. But when you look at all the possible causes that may happen and then take a proactive action, what you're then essentially doing is trying to remove the common causes of variation. And finally, your organization may have some actions taken database or risk database, which we should refer, by the way, not can. And then that can probably help you to, make your process better, right? But at the same time, what should you do if there are common causes? Like, for example, if I go back to this chart, what do I control here? Because I don't see any signals. I don't see any outliers, right? So what should I deal with? Even these points, though they look higher than other points, but they're still within the control limits. So what can I do? So when there is a common cause of variation and you still want to, reduce the variation, you want to still improve the mean. Remember one thing, common causes cannot be removed. They can only be controlled. So you have to first understand what are the natural bounds of your process, fragment the data, try to find where the bug is hiding. Maybe you have data on service defects, right? But maybe you have not grouped that data into different types of service defects. If you just group all the data together, your process looks stable and you don't know why it is not decreasing beyond a certain limit. In such cases, you need to actually group your data, fragment your data, split your data into different categories of service defects, or it could be software defects. And then you might find in one of the category, there is an outlier, there is a signal, which you should take care of, right? Maybe, so those who are in the manufacturing industry, maybe you need to increase the sensitivity of your measuring tools so you can find some more accurate data. And maybe that data can point to some variation which you did not earlier find or detect or identify. You can look at areas where there are wastes. There are methods to, to identify the wastes also or redundancies. Invite suggestions from people that you work with or who are the stakeholders of that process. Sometimes, people can come up with really bright ideas. Okay. They can tell you about some innovations. Like if you have been using an Excel to do most of the project management, that might not be a very efficient idea. Maybe it's time to move to some automated tool. There are so many tools available, and you will notice that your everyday time is also reducing. Okay. So you can do that, but then of course, don't forget one important point, which is budget. Controlling common cause of variation is not so cheap always. So make sure that you have adequate budget to deal with this type of variation as well. Okay. I hope that with this webinar, you have come to know about why variation happens, what could be the intrinsic or extrinsic causes of variation, how do we detect and differentiate between common causes of variation and special causes of variation. I showed you with one example. Try to relate it with your type of work, and then you should have good data. Remember, without data, all this is only concept and theory, which is why I showed you a practical example of, let's say, an incoming time. Likewise, you might have a lot of data which may be interconnected and interrelated. Try to use it to the best of your knowledge. Try to extract data as accurately as possible. Use some diagnostic tools, learn about it. And we are going to very soon have one more webinar in continuation of this topic, where we will take a case study. An actual case study of a process in a service industry. And there's a goal of improving a certain metric, certain thing that you are measuring. And so somebody wants to bring down something or improve something. And it was not happening by usual methods of process improvement and meetings, right? That you may do every time. So how could this concept of understanding common and special cause of variation help? So very soon you will be shared the information about that webinar, but this first part was necessary to bring you all on the same table for understanding these concepts of variation. I want to thank ISACA, which has taken over from CMMI Institute, and for providing us with the logos and allowing us to use their logo. Thank you to the digital marketing team at CUNIX. Thank you to delivery team at CUNIX for all the data and information. And some of the concepts have been referred from the high maturity concept training, which is released by ISACA. So I would like to acknowledge that as well. I'll be interested now to take up question and answers, but I again request you, no voice. Please type in your questions on the chat box and I'll definitely answer. So let's wait and let's take up some questions. Meanwhile, I'll just share the contact details in case some of you wish to have more interactions with me. So here are my details. Okay, so let's wait for some questions. There is an interesting question. Thank you so much for asking. So the question is, can common causes variation also contain hidden special causes? The answer is yes, it can be. So let's say if you remember that graph where there were no special causes, this one, right? This graph. Now if this is only office time, but if you split this into time taken from home to elevator, elevator to ground, ground to office building, building to something, you might still see some signals, some process that is varying too much. And when you split that data, there could be something hidden, which is what I mean by saying, where is the bug hidden? So you might have some hidden signals. For that, you will need to fragment the data. And then hopefully, if you find such an outlier, you will be able to investigate, you will be able to take action, and finally, hopefully, you'll be able to improve the process, whether it's a reduction or it's an increase. I hope that has answered your question. So thank you so much for asking. Okay, another interesting one. Uh, are control charts the only diagnostic tools? Well, no. Control charts are not the only diagnostic tools. Uh, for example, if you talk about outliers, okay, and if you have heard about box plot, which is another statistical method, it also helps you to find outliers. So it's just a way of representing the data. Box plot has a different purpose where you want to see where the volume of data is saturated, whereas in control chart you don't want to see the volume of data, you just want to see the process stability. So yes, there are many other techniques available for checking whether there is an outlier or not. Again, thank you so much for asking that question. And next question, where if processes are stable and within control limits, then in this case, should we apply heavyweight causal analysis and resolution? Well, you can always apply causal analysis, because even if your process is stable, if you're not happy with the mean, so the question is, are you happy? Is your customer happy? Is your management happy? There are no outliers. There are no extreme points, but are you happy? Is it serving your objectives? Is it aligned with your business and process objectives? If the answer is no, then as I said, there is always a difference between root causes and all possible causes. So in the question that you have asked, where the process is stable, you don't have a signal, but then you can always use causal analysis methods like fishbone to find out all the possible future causes and take actions. So I hope that answers. Okay, so let's move ahead. But of course, if you have still more questions, you can take a snapshot of this page and please reach out to me. I have given my email address, Skype, and my phone number. I'll be happy to reach out and resolve your queries of this topic. Let me now make an announcement. So CUNIX has scheduled some, being the CMMI partner, so we have scheduled some virtual trainings. These are official trainings for those of you who want to become ATMs, or that is appraisal team members, or you are an existing appraisal team member but you want to upgrade. Maybe you are CMMI team member for version 1.3 and you want to get upgraded to 2.0, or well, you're an ATM but you want to participate in a high maturity appraisal, which is when you need a high maturity concept training. So we have some dates here, and we also have the training topics. Now, for example, we have trainings on 5th and 6th September, 7th and 8th, 12th and 13th, 14th and 15th, and 19th and 20th. So practically from 5th of September to 20th September. So each one is a 2-day training. Now, if you register and communicate your interest before or on 22nd of August, we are happy to announce a flat 15% discount on the actual rates of this training. If you want to know the actual rates of these trainings, any of these, I again request you to take a snapshot or a screenshot of this. You can reach out to this email address and this contact number that you can see on the screen. And you can always ask what are the standard rates and what are the discounted rates if you approach before or on 22nd of August. So I would be very happy if you all show interest, if applicable, please reach out. And in the meanwhile, I hope you have taken the snapshot. I'll just keep the screen on for a few seconds just to inform that these are some of the areas in which we deal with, that is CUNIX deals with. If any of these areas are pertaining to your work and you would like us to guide you, and if you are looking for some specific certifications, or may not be certification, but as you can see from the fourth part or the fourth chunk, which is some knowledge-based trainings, then please reach out to us. We will be happy to assist and guide you further. So you can take a snapshot of that too. And with this, I really thank all of you for being there for this presentation and for giving your time. I'm happy for more participation in future. And as I said, those of you who have joined today, we will reach out to you in case you have more questions, and we will inform you of upcoming webinars. So thank you very much for your time. Appreciate some of the beautiful questions, and thank you very much and stay safe. Thank you very much.